The angle between vectors is actually a simple concept. All you have to do is memorize the definition of the dot product, which is vector A dotted with vector B is equal to the magnitude of vector A times the magnitude of vector B times the cosine of the angle between the two vectors. Then you can take that equation and reorganize it in a way that best fits your circumstances. For example, if we want to find the angle between the two vectors, we can divide the magnitudes that are multiplied over to under the dot product, and then we can take the cosine inverse and we get the angle between the two vectors. Here is an example problem that we are going to be working on. We have this structure that has two cables that go from point A to point D and point O. We want to find the angle between these two vectors. I have noticed that many students see this problem and assume that they need to find the components of the force in order to find the angle between. However, this is not the case. If we look at the equation that we derived at the beginning, I'd like to focus real quick on the part that is inside the arc cosine. We notice that that can be separated into A vector divided by its magnitude and B vector divided by its magnitude. Those are unit vectors of vector A and B. So all we need to do is find the dot product between the unit vector of A and the unit vector of B. This means that we should find the most direct route to finding the unit vectors, which in this case would be finding the position vectors and then dividing the position vectors by their magnitudes. This means that the force is irrelevant to this question, which makes sense. Whatever the force is inside the cables, it isn't going to change the angle between the cables. So now let's find the position vectors. We will take the coordinates of point D and subtract the coordinate of A from it, and we will get the position vector AD. We'll do the same with the origin and point A. Then we'll find the magnitudes of these position vectors by Pythagorean theorem, and then we will just have to divide the position vectors by the magnitudes and we'll get our unit vectors. Next we'll take the dot product between the two unit vectors, and then finally we'll take the arc cosine of those values and we will get a final answer of 38.1 degrees between the two vectors.